right? For our next example here, random sample of 6 mobile devices, so n is 6. Mean repair cost from that sample, so that's x bar of 85. Standard deviation from that sample, so S is 13. Assume the population is normally distributed, use the t-distribution, and construct a 99, sorry, so 0.9, C equals 0.99, or in other words, the probability would be 0.01. Okay, and our n of 6 gives us a degrees of freedom of 5. So if we're going to go ahead and do this, so we have to get the margin of error, TCS over the square root of n. I got to look this up. I'm just going to modify what I have here to show a probability of 0.01 and a degrees of freedom of 5, giving me 4.032. So I get 4.032 times S 13 over the square root of 6, and all of this comes out to be approximately 21.40. So again, now I'm just going to take x bar and subtract that, take x bar and add that. All right, and so if I do, what is the x bar, 85 minus 21.40, I'm going to get, what am I going to get there, 6360. And if I add e to that, I'm going to get 85.00 plus 21.40, and I'm going to get 106.40. We had calculated e to be 4.032. And again, with 99% confidence, it can be said that the population mean repair cost is between these bounds. All right, on to the next example. All right, so now we have to decide which distribution we're going to use based on what we're given. So we want to construct a 90% confidence interval for the population mean. Okay, random sample of 49 people. N is 49. The mean body mass index was 27.1. So that's our x bar is 27.1. And the standard deviation was 6.03. So the standard deviation was from this sample. So this is an S of 6.03. All right. So what did they tell us? Well, the key thing here is that sigma is unknown. Okay, and we don't know anything about the population itself, so we're going to use the fact that we do know that n is greater than or equal to 30 since it's 49. We were to get that it's random. And so we're going to use the t-distribution because of that. Okay, so I'm going to go down to the free space down here and do the calculations. Okay, they wanted a confidence level of 0.90. Means the probability is going to be 0.10. Okay, we did have n of 49, meaning that the degrees of freedom would be 48. So if I go and calculate E as TCS over the square root of n, remember because we're using the t distribution, all right, if you look up the critical value of t, I'm going to skip that part and tell you it's 1.677. So we get 1.677 times S. So S from above was 6.03 and square root of 49. And from this we get approximately 1.44. And we're just going to take that, use it to build our confidence interval. So X bar was 27.1. I'm going to subtract 1.44. I'm going to add 1.44, giving me 25.66 and 28.54. And that's going to be my confidence interval. Right, so we said 25.66 and 28.54. All right, and again, with 90% confidence, we can say that the population mean is in between these bounds. All right, let's take a look at this last example here. Again, we have to choose and see what we can do. Gas mileages in 23 random sports car listed in the table below. Okay, so N is 23. Mileages are not normally distributed. All right. And then we should choose a distribution or explain why we can't. Okay, so here's the thing. The population is not normally distributed, so we better have at least a sample size of 30 if we're going to use either of these. We do not. So we can't use either distribution. So neither can be used to construct the confidence interval, since the population is not normally distributed and n is less than 30. So we can't proceed. That's the end of it there.